Hey there and welcome to another processing tutorial. In this video I'm going to explain, or I'm going to show you how to work with waves in processing. So waves are basically functions in processing that you can use to move values inside of a specific range, right? But in this context of creative coding and generative design, we can use waves to draw or paint beautiful pictures onto the canvas, right? Let me show you what I mean here. So let me just go over to my code editor. This is a piece of code I've prepared for this tutorial, and it draws or it paints that image to the canvas. Well, basically the thing is about wave figures, it's a huge world of possibilities in there, right? So just tweaking a few values produces completely different visual results, which is very, very exciting and very, very interesting from my point of view. Okay, nice. So on the right side of my viewport here, you see the code I've written a few hours ago to prepare this tutorial, and on the left side I'm going to recreate that code from scratch. So I just need that on the right side to take a look at it and maybe see if there's something wrong in my code here. Okay, alrighty, so let's get started. As always, we create the setup function in processing. Inside of the setup function I create a size function which defines the dimensions of the sketch. I always set this to 900 times 900, but of course you can use any format you like. Okay. Now I will create the draw loop, which is the place, or which is the piece of code that executes 30 times a second in processing. So, and I will paint the background black. And this is basically the very starting point of every single processing sketch I create, right? Okay, nice. Let's shift everything to the middle of the sketch window with the translate function. And just to make sure this worked, I will create an ellipse in the middle of the sketch window to see if that just worked out, right? So the ellipse has a position of 0, 0, because with translate, I just shifted the whole coordinate system to the middle of the sketch window, and the size of the ellipse should be 50 times 50. Let's see if that works. Run the code. Yes, here we are. There's an ellipse in the middle of the sketch window, and the sketch window is black. That's pretty cool. Okay, nice. So, because maybe you know that the draw loop, or that if we place the background function into the draw loop, it kind of clears the background every time the draw loop executes. So that's not exactly what we want in this sketch. We want to clear the background once in the beginning when the sketch is executed the first time, and then we want to paint onto the canvas, onto the sketch window, right? So that's why I just moved the background function from draw to setup. All right, cool. Now I would like to move that ellipse from the left to the right with a wave motion, right? So let's create a variable that's called wave equals to, and now it's getting a little bit complicated. Please take a close look what I'm doing, because that's sometimes it can overwhelm you. But in my course Creative Coding Essentials, I'm going a little bit deeper into that topic of wave motion. So map, the map function is an essential function in processing which enables you to map one area of values onto another, right? Map scene, this is the sine function which creates a sine wave, right? Into the sine function I put the radians function to convert radians to degrees, right? Or basically convert degrees to radians. I think that's the right way to say it. Yeah. And in there I put the frame count, right? Which is basically the driver of the wave, right? So, and because I'm just going out of space here, I'm just putting that full screen now. Now, the map function receives 5 arguments. This is the first argument. This is a wave that I'm generating here. And the wave is creating a value moving between -1 and 1. And that's why I'm going to put a comma there and say comma -1, comma 1. This is the original wave, the original value range of values that I want to put into another range of values, right? -1 and 1 to -200, 200, for example. So that would now create, or this value here moves from -200 to 200, right? So, and if the frame count reaches 360, then it is back at the original position. Okay, I know this is a little bit overwhelming. Let's see how that looks. Maybe that makes sense then for you. Here we are. Now we've got an ellipse here, which moves from the left to the right, right? And back again to the right, to the left, to the right, to the left, and so on. So this is a simple wave. Thinking about, can I just deconstruct this or make this a little bit easier for you to understand? I know, this is a lot. This is math, right? You definitely have to take a closer look onto this. This is not something you're going to understand in just 5 minutes. It takes a little bit of time, but it totally makes sense, right? It's totally logical. Okay, nice. So let's create another wave. And in this case, just for demonstration purposes, I will just call this one wave 1 and the second one wave 2. And the second wave will be controlled not by a sine, with the sine function, not generated by the sine function, but with the cosine function, which is kind of the opposite of the sine function. When I run the sketch now, I will get a circular movement, right? So there are two waves affecting the x and the y position of the ellipse, and together they end up in this result, right? In this very nice circular movement, which is pretty cool, I think. Okay. So the cool thing is now that we can kind of deform the circle now. Maybe let's quickly clean up the code a little bit. Let's say let's create a variable called mag for magnitude, right? I want to store the magnitude of this wave in a variable called mag. I will put this to 400 because the sketch window is 900 pixels, and this is probably, well, this won't touch the edges of the sketch. And when I do so and run a sketch here, I will get this result, right? So this is a very nice large circle. And I want to deactivate the stroke. No stroke. So that's how I achieve a more, let's say, a very, very plain shape here, right? So now take a close look. This is going to be amazing. So both waves are controlled by the frame count, right? They are controlled by the frame count. So what if I multiply, or I just want to slow down one of these waves a little bit, right? Let's say frame count times 0.8. So let's see what happens now. Whoa, can you see that? This is not a circle anymore, right? Now it creates something like this is a so-called Lissajous curve, right? So this is a mathematical phenomenon, very interesting. So this will, at one point, this will close and end up in a perfect shape. Let's wait for a moment. Okay, there we are, right? So I always find this very magical when I see this. So this is beautiful. This is math. This is nature, right? So cool. So let's set this to 0.5. Let's see what happens now. Okay. It looks like it creates an U or an V, something like that, right? Yes. So that happens when we put that to 0.5. So if we take some weird numbers in here, right, then it will probably never ever touch or never end up in a perfect shape. It will always be a little bit irregular. I guess after a few hours running that sketch, this will be just a white square, right? Which is kind of exciting and very interesting, right? So waves are magical. Really, I love them so much. Okay, let's move on here. Now, so let's do something. Okay, let's put that whole thing into a loop, because I don't want to have just one ellipse. I want to have multiple ellipses. So for int I equals to 0, I is smaller than, let's say, 100, I plus plus. Okay, so now I have a loop that executes that piece of code 100 times, right? So the result will be exactly the same, but the thing is that now instead of just having one ellipse, now we have 100 ellipses that are stacked on top of each other. What I have to do now to first of all, let me just go back to into the other mode where it just creates a very interesting Lissajous curve, this one. And let's add here we have to add I into this phase, right? This is the place where we put the phase, the so-called phase of the wave into in degrees, right? So if I say plus I and then I run a sketch, I have more than one ellipse moving here, right? So this is always fascinating. I didn't expect that result. That's really cool. But now I have 100 ellipses that all have a slightly different position. Maybe it's a good moment to change the size of the ellipses. Let's say S for a size, or is that a good name for a variable? I don't know. Let's call this S, and let's say the size is 10, and let's put the variable S into the ellipse function here. And now we have much smaller ellipses. And they interestingly, on the x-axis, this is more like a row of ellipses, right? So let's put I into the second wave as well. And maybe we can resize a little bit more to, let's say the size should be 3. That's much better, I think. Okay, now it looks a little bit more organic. It is not just like putting white paint onto a black sheet of paper. I don't know, right? So this paints a very, very nice Lissajous curve onto the sketch window, right? This is a very, very interesting motion, I think. Cool. Okay. So what I also did in the other sketch, I created another wave which basically affected the fill color of the ellipse. So let's say float C, which represents color, right, is map SIN, radians, frame count. Again, it's the same as here, right? This is how I always create a wave. This is the standard way, my standard way of creating a wave. Comma, -1, comma 1, comma minus, no, sorry. Now I have to set the range for the fill color, and it is 0 and 255. So this will now fade from 0 to 255, right? And also here I will put I into the phase, right? This is the phase, PHSAE, the phase of the wave. Okay? And now I have to use the fill function to define the fill color of the ellipse, and let's see what happens now. As you can see, the ellipses that are drawn onto the sketch window now they vary in their color, right? So that's pretty awesome. They just fade from white to black to white to black, from white to black, which is really beautiful. I will change this to rect because rects have a little bit more, they just fill a little bit more space. And I will just let's say I will fasten the wave of the color, right? Let's say ×2. That should work. Okay, it's always, wow. The thing is, it looks a little bit three-dimensional because of the black and white color fades. And I think maybe now it's a good time, because we are now working with these colors, to reset the size again to 20 or something. This will be more this looks a little bit more like a three-dimensional object or something. Very nice, very cool. Okay. Now, I like that this shape, or that this Lissajous curve is quite, let's say, regular, and it looks a little bit mathematical. But what if I want to have it a little bit more organic? So I could imagine that there could be something like a third wave That's, by the way, what I did in the other sketch as well, which is, let's say, which is a variable, or which is a wave that moves inside of a specific range that I will put into the phases of these waves. Let's call this W. I know this is a little bit weird naming, but I don't know. I think it's okay. Let's do this. Sine, radians, frame count. As you can see, always the same, right? Writing a wave is always the same. Map, sine, radians, frame count, comma, -1, comma, 1, comma, and now I have to define the range that I want to have. So the range I want to have is 100, 100, for example. That could be a good range. I don't know, to be honest. I don't know how this visual looks after this tweak. Let's see. Okay. Yeah, wow, this is cool. Nice. Okay, this is pretty awesome. I think the color or the fade between these two colors is a little bit too slow. Let's say it could be a little bit faster. Let's say 5. Let's see how that looks. Okay, now we get these very, very interesting gradients here, right? So we get very clear gradients, which is cool. It's pretty cool. Let's scale the sketch to 1920 times 1080, which is HD. Yep. Right, this is cool. I mean, this could be a branding, or this could be something like a, you know, like a generative branding system or something. It's really, really nice. So be prepared. Now I'm using a super powerful trick. Okay, so what I'm going to do now is changing the whole thing here. It's going to make this very, very cool. I hope. Now, we have 3 different functions, or I use 3 different functions to generate waves in processing. The sine function, the cosine function, and the tangent function. So the sine and the cosine function create a wave that goes from the left to the right, from the left to the right, okay? But the tangent function does that the wave goes with exponential speed out of the screen and coming back from the other side until it reaches the middle, right? And then how to say that? I forgot this word, but it gets faster, right? It just goes out of the screen and comes out of the infinity back into the sketch window, and then is in the middle of the sketch, which is pretty amazing. So the tangent function is pretty nice, because we can, when we already have a nice, let's say, wave made with sin, we simply can switch this by changing the word sin with tan, and let's see what happens then. Yeah, let's try. Whoa. Okay. So, it moves out of the sketch window, goes into infinity, comes back into the sketch window, and goes much slower in the middle. Okay, let's change the magnitude. Let me just think quickly. Let's change the magnitude here to 100 instead of 400 to kind of compress the magnitude of the wave a little bit to the center or to the middle of the sketch. Wow, this is so cool, right? So it reminds me a little bit of a snake or something, like a snake motion. I don't know. It's a little bit red. What kind of patterns happen, or what kind of patterns are created here on the edges, but anyway, I like it. It's pretty cool. What happens if we change the size again to, let's say, 5? So this gets a little bit more, yeah, organic, I think, right? It doesn't look that computational from my point of view, but yeah, it creates a lot of chaos here, of course. Okay. By the way, we can take the background function, put it back into the draw loop, and this will create a completely different result, right? So then we just see these rays, or these little things, that these kind of glow worms that create that visual, right? I think this is beautiful. Let's change the size to 25 or to 15. Let's see how that looks like. Wow. Pretty awesome. So as you can see, I mean, wave motion has so many potentials, right? And I really, really enjoy just playing with these, and I'm just so happy to see how these beautiful elements dance on the sketch window, right? So let's do one last step. First of all, let's put the background function back into the setup function. And in the next step, I would like also to change the cosine function, swap it or switch it to a tan function. This is the function that affects basically the vertical positions of these rectangles. And this will create a completely different result, right? So now we have a tan wave on both axes, right? On X and on the Y axis. So horizontally and vertically. Okay. Yeah, I mean, this is very close, right? This comes very close to the other sketch. Let's just compare them and see if that's the case, right? Yeah, I mean, this is a little bit more beautiful. I don't know. I did something different here. I'm not really exactly sure what, but basically, this is how to work with waves in processing. This is basically how to create these wave figures in processing. By the way, this is one of the exercises in my Bauhaus coding workshop. If you're interested to learn more about processing, check out my Patreon and my website. There are some courses on there. So there I explain many of these concepts in detail. I hope you enjoyed the video. Feel free to comment, share, like, subscribe. I'm very happy for every follower, and I wish you a wonderful day. See you soon. Bye.